Hello, in this video you will learn specifically how to use RabbitMQ in C#.NET 10. Now it's not about the theory and why you would use this over other tools, but we can begin with a setup in Windows in this case, but it could run of course on Linux servers and all those things. You can do this quite easily. So first thing you need to run this tiny Docker script essentially. This is for a basic setup. We'll a bit later look at something a bit more complex where you can change some basic settings essentially. But this is quite straightforward. So essentially what you get here, you get the setup for actual RabbitMQ, and you also get the setup for this manager that you can see. The manager helps you sort of set up the channels, and there are some useful things. So essentially you just run that and you will be able to access the manager via this localhost 15672. So that's the number that will be accessible for this panel. The panel offers a few things here. Just one thing to note, in some browsers, in some cases, it may not work. It will just throw error. What you then want to do, don't start messing with settings or anything like that. Just try a different browser, or even in incognito mode in your current browser. It should be perfectly fine. So in general, you can, of course, overview the performance. More importantly, you can look at the streams, and also you can set up these exchanges. Now, once we get into the code, it will become more clear what they are. For this purpose, we will basically just use default, but there are several options. Let's just take a quick look at those. Now, as far as theory goes, the director is essentially a point-to-point system, so there's no sort of explicit configuration for any of it in terms of routing. The fan-out we use when we want to connect to essentially multiple queues and consumers, rather multiple consumers, not multiple queues, so for perhaps notifications and things of that nature. Then the headers, kind of a more stricter perhaps arrangement. It is for attribute-based scenarios, and the topic exchange is just the messaging, sort of debugging and tracing topics. But again, we're not about the theory here. Perhaps we'll do a sort of separate video in the future for more advanced topics, advanced setups, and get into the actual theory and proper sort of use cases later. However, one thing important to mention here, in this whole arrangement, we have this add new exchange, but you can also go into existing exchange, and you can also send these messages as a little test arrangement perhaps. So it can be quite useful. It is a bit hidden. Of course, probably not very useful, but in some cases for sort of very quick and desperate, perhaps debugging might be extremely useful. Other than that, we have channels, we won't get into them, and we have connections, so you would see the connections if any of them are live, just a simple overview. You also have the admin tab, you can add administrators, but there is another way to sort of set it up, a bit more extensive, so that is with Docker Compose, and you can add a password just in your container setup. You can actually add a different password, a different username when you log into this thing. By default, it's guest, password, and username, which isn't very secure. However, one thing to explicitly mention in this case, if you are running this on a server, on a Linux server somewhere, on a VPS or somewhere else, the best thing you can do is not the password. Of course, you should add one, but you should secure your actual IP address via a firewall, the port, the IP address, and all that. So you need to add those restrictions, because no password will be really all that good enough. So it's something to remember. Now, we can get into the actual example and take a look at that. So for the example, we have in the code essentially two .NET 10 program applications, or console applications, but program.cs files for those two programs, if you will. And one is a producer, which actually sends the message, and the other one will be a receiver, or rather consumer, the technical term would be, which receives the messages and takes them into the queue. So before we begin any further, we have to look at the NuGet packages, and they are very few of them actually. We just need the RabbitMQ.Client, and this is again one of the advantages of using RabbitMQ. There are, of course, performance considerations and use cases like that, but the setup is actually very straightforward. You only need to install a relatively simple thing in your Docker, set up a very basic, essentially Docker container setup, and then you just need to install one NuGet package and you're good to go. So let's get back to the producer. We have here, first of all, the factory. The factory is kind of like your connection setup in SQL Server or something of that nature. You just set your host name. Of course, it will probably be IP address in production scenarios. And then you have your port and your username and your password. So the credentials are, of course, very important. That way we can secure it. But as I mentioned previously, you do need to have that port secured via the firewall. That's the best way to do it. Other than that, before we begin sending messages, we need to create two separate things. So the first one is a connection. Now, connection, you do want to reuse. The channel, you want to recreate sort of quite often. But connection is quite a heavy thing to do, so you want to keep reusing that. And of course, you will. And again, maybe we'll make a different video on sort of more advanced patterns, but just remember that connection can be reused. Channels should be recreated. They are quite lightweight. So each channel will be for different arrangements, but essentially the queue is what determines sort of connection reliability. So from where you connect to where you connect. You create your channel. There are some options in the channel. We won't get into those. The most sort of important, at least in a basic setup, is the actual options for the queue creation. So we need to declare it. And then once we have that, we will send the message. So the first thing is the queue name. And in fact, we can actually jump real quick into the consumer part. And as you can see, the consumer part will have essentially the same thing. We create a channel, we create connection. So exactly the same sort of an arrangement up to this point, at least. And also something quite important to note, the QueueDeclareAsync, it's exactly the same as well, and it has to be exactly the same because otherwise it won't work. So of course, the main thing is the name. The names have to match. Then you are connecting to the same connection, to the same RabbitMQ instance, essentially. You create channels through which you send those messages and queue them. But then if you want to consume from a specific queue, you have to consume from that specific queue, and you can create many of them or a few of them depending on your needs and depending on how you actually approach this. But let's get back to the original one and let's take a look at some of these options, shall we say. So durable essentially will kind of keep those messages written into your device. So if it restarts, if something fails on your server, those messages will stay alive. Now, we are not enabling this. In this case, it is a bit more of an advanced feature. We might again do another video on those. We need to go back and forth between the manager and just kind of to see how it would actually work. But exclusive, we would again need to set up this one connection with a few more options. So we can do it like that, but we won't be doing that. And auto delete, then after some time, it will essentially be deleted. Just to explain something a bit more, these messages, whatever it may be, they get sent to the server where your RabbitMQ is. Now, it may not be a server, it may be a container instance, but of course containers do run on servers. Whatever arrangement they may have, it's not some magic, it's a server. So essentially these messages stay on that server. And then once your consumer connects and starts consuming them, they get consumed. Now, they do get acknowledged and all that. We'll get to that in a bit. But auto-delete essentially will delete after some time when it's not used. Then there are some arguments which we'll get into. A little console here, right line, just so we can see. And this particular example, it will send 5 messages. And the interesting thing, just to compare to, say, a simple TCP socket, because this is essentially TCP socket connection, is just that there's a sort of storage in between. If you have a TCP connection and we have, say, 2 console applications like this, you would have to start the server one first, so it can wait for connections, and then the client would send the messages. But here we can start whichever one first, right? We start the client, sends the messages, doesn't matter. Later we can even turn off the client and then consume the messages on this server, as we might call it. It is the producer rather on the consumer side. We can just turn that on and consume it, and they will be there, they will be in the queue. So that's kind of the point of this whole thing. Now, the actual message body, there are a few sort of important things similar to TCP body, which essentially it is, so we can't run away from it really. The message is just text, but you do have to get the correct encoding. So whatever you read, or rather whatever you write, you will have to read. So make sure you have UTF-8 get bytes or some other encoding, although these days there's very little point in using something lighter than UTF-8. It will just mess with you, and there's no reason to do that. Now, this is a bit of a mistake. Let's correct that. We always, unless it's some client part or user level sort of part, we always want to use UTC now, because of course, different servers may run on different time zones, and we always want to have a centralized time zone. And we just send a simple message here. However, something important to note, of course, you wouldn't be sending simple messages like that. What you would actually be sending would probably be JSON format. So you can watch one of the other videos on this channel, one of the quite recent ones, how to create essentially encode and decode JSON strings, convert from string to JSON object. Very interesting video, and of course for something like this, very useful, because you will need that sort of an arrangement to do it. You can of course just stream as bytes if you're streaming some heavier loads, but then if you're streaming heavier loads and not just simple JSON, perhaps RabbitMQ might not be the best solution, so something to consider as well. And then we just use basic publish. Now, if we go to channel, we have a few options, but as you can see, we have basic publish, so there's no really other kind of publish. We just have basic publish. There are plenty of options, and we'll get into it a bit, but that's how we do it. And remember, in the user interface, for the management part, the management is that little admin dashboard you saw in the beginning of the video. We saw exchanges, so you can create new exchanges of different types, and this, if it's empty, it will go into the default one. Now, usually you'll want to create not a default one, especially if you're using several. You don't want to mess with the default one. Just name them properly, because the name is sort of predefined. So if you have several of them, it might get confusing. Again, naming conventions do apply not just to code, but to extensions and to exchanges rather, and to RabbitMQ bits and pieces. So something to remember. but essentially then you just put in the name and then it will only use that exchange. Of course, on the consumer side, you will need to do the same thing to match it. And routing key, in this particular direct routing, we just route to the specific queue. So again, it's important to match the name, and then we just provide the body. So kind of like HTTP request body and a few details in the headers, if you want to think about it that way. Then we just wait for the next messages so we don't all come through right away, because that would be boring. But that's it, really. We sent it, and there's no reason to close anything. We'll leave it open, at least in this sort of case. Of course, again, you want to put this somewhere. You want to reuse it, the channel, you can reuse it on different instances, it doesn't matter. Again, that's not an expensive procedure to do. Now, let's take a look at the consumer side of things. We have declare async, queue name match, perfect, that's all we want. Then we need to also, we created connection channel, but we also need to create a consumer, okay? The consumer will have an event like this, and it will have some event arguments. So you create your consumer, you place it somewhere in your server, probably in a perhaps a .NET 10 minimal API even, it might be, right? If you want to get some logs from it, you might add minimal APIs, and we do have a video on this channel about that as well, about the security of minimal APIs, also validation, which is a new thing in .NET 10, so take a look at that, quite a useful thing. So we add this event on the received async, relatively straightforward thing, and just like any event works, once we get a message, right? Once we connect, we'll get a queue of messages and we start consuming. And again, the queue might be empty. Once we connect, it will be fine. But if you are already connected, it will have an event on which, when the message arrives, it starts consuming, and it will consume them one by one. So of course it doesn't crash and overload your whole arrangement. The body goes to byte array because that's what we sent, that's what we want to receive. And as I mentioned previously, we want to have encoding UTF-8 and get string. Again, encoding should match. That's quite important. And then we just simulate a little work task here, just for the sake of the example, so we can see that we don't receive, in fact, all of them at once, but receive them one by one. The most important thing, however, here, probably some of it also is quite important, but this is why we actually use it, for that sort of assurance that it actually works. So to not block the whole application, the whole consumer side of it, also to be absolutely sure that we received the message, no data got lost, the job didn't fail, your bulk job, whatever it may be. So for that, we use the channel, right? Not the consumer, but the channel. And in the channel, from the event arguments, we get this delivery tag. So essentially, it's the ID for the message. You might think of it that way. Nothing too fancy about it. We can acknowledge multiple. We won't get into that too much, but you want to do that as false. You could do auto acknowledgement as well, but it's best really to do it manually. So, you handle all of your exceptions and all that. And if it's thrown an exception, you won't acknowledge. And basically, you do it manually after all has been done. Of course, there would probably be a method here, and many methods perhaps. And then after all of it's done, after all of it's passed, you acknowledged, and then that message will not be sent ever again. It's known to have worked, and that's great. If, however, it fails, that message will be retried, and retried. That's kind of the point, so we don't lose the data. And then we just need to start the channel. Of course, this is event, so it won't start unsewn. we set up the events, and then we start consuming. So once you start consuming, it will start consuming, and it will essentially be firing that event whenever there is a message. And as I mentioned, we have the auto acknowledgement, but we usually it's best to use the manual one unless you're absolutely sure about it, or if maybe it is a throwaway kind of a job, perhaps a notification system that's not crucial or something like that. But usually we want to do basic acknowledgement manually. And then we set the consumer right here needs to match, of course, and the queue name as well. The queue name is quite important. Basically, once you create that queue, it will go back and forth, and that's one of the important pieces. You can find this example of code on Patreon. There's some other free courses for certain subscription tiers. And to take a look at the other videos for .NET 10, the minimal APIs, which can actually be quite interesting if you're running a server that actually consumes something for your logs and things. Might be a good idea to do one of those. And with that said, we will conclude this video.